Yeah, okay. So, brief history. It was developed by Bjarne Scherstrup in 1979. C is another language that is a subset of C++. So C++ has everything that C has. It just also has more functions and libraries that you can use. So statically typed means that variable types are checked at compile time rather than runtime. So if you put the word static before your variable, that's going to be compiled at compile time. So when you try to run your program and it compiles, those variables will already exist. And then this language is also an object-oriented programming language, which means that we're really revolving around creating objects, variables, and classes. So a lot of encapsulation and abstraction, which we will cover in later slides.
Yeah. Moving forward, why should we learn C++? Out of all the coding languages, why is C++ a valuable one to learn? One is just, it's a very generic programming language. You can do a lot of things with it. Welcome to our joiner. Schools such as the University of Michigan, which Alice and I both go to, in all of your basic classes, you're going to be learning C++ and using C++. So going into those classes, having at least some knowledge of C++ will give you an upper hand in those classes. Another reason to learn it is the syntax is very similar to C, C#, Java. So if you can code in C++, coding in those other languages will be very easy for you to kind of switch and code in those languages as well. And then, like I said, you can use it to create various things like compilers, databases, cloud storage systems. It's also used in game development, graphic design, and the list only goes on. And if you get a computer science degree and are very familiar with C++, you can actually land a job working on different apps. Just some examples are Spotify, YouTube, Adobe Photoshop, Illustrator, and again, the list just goes on. It's a very useful skill to have. And then just, you can do this one.
Sorry.
Okay, just some pros and cons with C++ as opposed to other languages is that for C++, it does have better speed and performance compared to languages such as Python, which is another popular language that you'll see in the computer science field. And you also have total control over memory management. And this is something that's different from Python. This can be a pro and a con because it gives a lot more control to the computer scientist, but that control, if you don't know how to use it, you can end up really messing up your program. So it's not really something that you'll learn too much about until you get to a higher level of C++. And then another pro, like I said, is just C++ is everywhere. And they're a large support system on forums. So basically, if you have a question, chances are you'll be able to find the answer to that question on forums like Geeks for Geeks or various other forums. And then just one other con is that it is a little bit more difficult to learn as opposed to Python. Python is pretty straightforward and it's almost like pseudocode. So what you're seeing, you're basically, and writing and reading is what's going to happen. C++ is a little bit more complex than that. But once you get a little bit familiar with it, it's not too scary. And then just getting started, we did share to the chat Replit. Is it just replit.com, Alice?
Yeah, so this is a website that is an online IDE, which means you can code programs inside this website in C++. So when you go there, if you don't already have an account, I think you need to create an account first to use it. And then you can start a new program using C++. There should be a drop-down menu when you click on new program or like the plus button, and then you can start that up.
Yeah, and then once you have that started, this is just kind of a basic format I have put on the screen. I think Replit already gives you some of this that you're seeing already, but I don't think it has the using namespace standard, which is that second line of actual code that isn't green, or the return 0. All you have to really worry about is that using space standard. It basically, if you see on your replit right now, your like C out statement for hello world is like standard : C out. Using namespace space standard just makes it so that you don't have to have that standard in front of different lines of code. I like to always include it just because it cleans up your code and makes it a little bit more readable, but it really is up to the programmer.
Yeah. Like for example, if you look inside the main function, the cout hello world, if you weren't using namespace standard, you would have to put standard : cout. So that just makes it quicker so you don't have to retype using like the standard : operator over and over again. If you guys want, you can just use a piece of paper to write out your code as well. I know that taking time to make an account can be annoying. So we can also just take a look at your paper or your code either way.
Yeah, because we are just going to have a couple example problems to think through, and you don't even have to write them down if you don't want to. It's all just whatever you guys want to do, but we will have those in case you want to work on actual coding. But yeah, going forward, here are just kind of the building blocks of C++, and we're going to go over all of these in the next slides, just to kind of give you a foundation of where to work off of, and you can always refer back to these slides when you're creating programs on your own.
Okay, so statements, these are just normal lines of code that you would type. Each line of code in C++, much like Java and C, must end with a semicolon. That is signifying to the computer that this is one statement that you're saying. So example, already in Replit, if you've made an account / made a project already, it comes with this, the cout hello world. So cout means print. You're printing to standard output. Hello world is a string you're printing, and then endl at the very end of that means a new line. So you'll start on a new line after that. Another example of statements are setting integer variables to 1, like int num x1 equals 1, and then the next one equals 2. You can use either format of syntax to do that. And then blocks of code are put inside of the curly brackets. So if you're using like an if statement or an if else statement, you're going to want to put those brackets in there to signify what should be inside the if and what should be inside the else. Also used for loops, which we will see later.
Yeah, and then moving on, we have our operators. You're going to see this in basically every single coding language is going to have operators. And they're basically just used to perform different operations with objects of the same data type. So unary is going to be your plus plus minus minus. There are other ones, I believe, but let's just stick to plus plus minus minus. And you can see them. I put out an example. So if you have an integer counter set to 0, plus plus is going to say, okay, counter equals counter plus 1. So it's basically just saying, let's go up by 1. And then minus minus is just going to do the opposite. It's going to say, let's go back down 1. And then looking at our binary operators, we have arithmetic, which is just our basic algebra. We have addition, subtraction, multiplication, division. And then modulus, which I'm not sure if you guys have heard of before, but it basically is when it's the remainder of when you're dividing something. So if you were dividing or if you were to take 9 modulus 4, it would be 1 because it's a remainder. You have a remainder of 1, if that makes sense. And you can always look into this a little bit more online. It is very useful to understand it for different projects, but we're not really going to be dealing too much with modulus, so I don't want to go super in depth to that. And then you also have your logical operators. So that first one we have there, those 2 bars, is your or statement. So this or that, as you can see on I think that's slide draw. I'll have to fix that, but that's your or statement. Next one is your and. So this has to be true, and this other thing has to be true. And then the next are pretty straightforward. The exclamation point equal sign is like, it is not this. Equal equals is, it is this. And then the rest are just basic operators you've probably seen in math classes.
Okay, so loops. Just to heed the initial warning, loops are going to be repeating your code multiple times. So when you make a loop, you want to make sure that you're not letting it run on forever, because infinite loops will cause your program to crash. They'll probably cause your computer to crash if you're doing some intense programming, and just not a great place to be in once you're in the middle of an infinite loop. But let's go over the syntax. So a for loop, if we look at the top left corner, we have a for loop in C++. Have you guys seen a for loop before in different languages or at all? You can type in the chat this answer. I'll just keep talking. But either way, the syntax here is that we have an int I. So we start with for, and then we have an int I. This variable I is a counter variable. So it's going to be set to 0, and then the next statement says I less than or equal to 5. So we stop this loop when it is not less than or equal to 5. So it's basically going to do printing a loop and then the actual I variable. As you can see in the little black box, loop 0, loop 1, loop 2. And that's how you do a for loop in C++. A while loop is going to be basically you're doing something until your statement is false. So if you look at int count equals 3, and while in the while statement is saying while count does not equal 0, that basically means like we're going to continue looping through this until count is not 0. Like, yeah, sorry. So we say cout count more loops, and then that's the output in the black. And then the do while loop is very similar. We just make sure that we do the stuff in the while loop first without any condition, and then we check the condition at the end. So while loop is checking the condition when we first start the loop. The do while loop is first executing the code and then checking the condition to see if we should keep going.
Yeah, and then moving on, we just have a little practice problem. It's to make a 5x5 box of stars using if statements and a loop. Below are just kind of some things you might find useful. How are you guys feeling? Do you want to work on this like right now? Do we want to kind of just show you the answer? What are we feeling? Do you want to just say in the chat? Okay. I guess we can just give a couple, maybe like a minute just to kind of like think over what we're thinking, and then we'll show the answer. Okay, and I guess we can just move on to the answer now. So here's the answer on Replit. You basically just want a for loop of 0 to 4, because remember it's I less than 5, so we're not actually going to hit 5. And if it's the first line or the last one, we want to print all of the stars. But if it's any of the other lines, we only want to print those outside stars. So that's just some explanation behind this code here. If you have any questions, you can always go back. But just moving forward, next we're going to be talking about functions. So functions are blocks of statements combined into one unit, which can be called and used in other parts of code. And we're going to show an example in a minute, but just kind of reasons why we would create functions. One, it's a lot easier to have functions than one continuous stream of code that's like thousands of lines long. Why not have 100 different functions with a lot less lines in them? It just helps break up the code. Another reason is that if you're ever going to have repeating code, why have repeating code when you can write it in one place and just call that one place that you wrote it to? And then kind of the Third reason is it's great for collaboration. So if you're working on a partner with a project, you can say, okay, you do this function, I'll do this one, and then we'll bring it together and hopefully we'll have a working program. And when you can call a function varies, but anywhere that can access a function, which I know can be a little bit confusing because you can actually even call a function inside of itself, which is recursion, but we're not going to get too much into that. That's something you don't really get to until I think it was like our second class or second or third college level class that we started looking at that. So we're not going to worry about that. And then, yeah, here's some examples of functions. This is just going to increment what we're taking in by 1. And there's 2 different ways we can approach this. On the left way, we are taking in main A, which is set to 5. We're taking it in, we're making a copy of it, calling it A, incrementing it, and returning what we increment. So we're returning 6. So the actual main A is not incremented. The incremented A is set to the increment of main A. But on the right, we're passing it by reference, which is basically, instead of making a copy of it, saying, I want to actually change the actual code. And there are various reasons why you would do this. One, it comes down to size, how often you're going to be calling it. But for now, I would say probably just stick to pass by value, which is the one on the left, which makes a copy of it.
Okay, so arrays is one of the very basic data structures in almost every single language you will encounter. So arrays are a series of elements of the same type, contiguous in memory. So that means when you store it in memory, if you picture memory kind of like a bookshelf, all the books, all the data are going to be right next to each other. So in C++, when you store an array, everything will be right next to each other in memory, and that will be useful for later things called pointers, which we'll review. But basically, arrays are also, you cannot resize them. That's the big thing about arrays. They're contiguous in memory, and you cannot resize them. So once you start storing things in arrays, if it gets full, you can't add more things, basically, or subtract the size. You kind of have to deal with the size of the array. So if you look at the example at the very top of the gray box, it says int foo5. When you declare a single array like this, you need to put in that 5 because it's a fixed size. So when we declare it, we want to give it its fixed size. Otherwise, there will be an error. And then we have a for loop looping through it. And you can kind of look at the code if you would like to see what it's doing, look at the results. But basically, the point of this is just in C++, this is also a zero indexing language, which means that when you're counting an array or just starting from somewhere, you always start at 0 and not 1. So in the real world, we like to count based off of 1. So if we have 5 apples, we would go 1, 2, 3, 4, 5. But in C++, we would go 0, 1, 2, 3, 4. But yeah, those are arrays.
Okay, moving on to strings. So I'm sure you've seen strings before if you know Python or pretty much any other language. I just thought we should have a slide for it because strings are a little bit special in C++. Sorry, my computer is dying, so I just have to relocate real quick to somewhere where there's an outlet. But here, Alice, could you take over this one real quick?
Yeah, I got it. You're good. So strings in C++, as you can see in the gray box at the top, we start by saying string. We have to include the string library to use strings in C++ because it's an additional class. But basically, we name our string and then we set it to something like hello. There are 2 types of strings. There is a C string and then a C++ string. So the C++ string is the first example in that gray box. Very easy to use, pretty intuitive. It's like what you'd expect, similar to Python if you've ever seen that. However, C strings, like I said earlier, C is a subset of C++. It was an older language, and it's a little bit harder to understand. A C string is just an array of characters. So as you can see on the second line of code, char c stir 6, we have world, and then we have this little null value at the end. That null value is signifying that your string, your C string, has ended. You don't really need to know about C strings that much. The main point is C++ strings, which are much more intuitive, but thought we'd make you aware just in case.
All right, and then we have another practice problem right here where you can make a program that takes in a user's first name and outputs hello and then whatever their name is. I showed an example here, and just some things to consider at the bottom, but we are running a little tight on time, so I think we'll just show you the solution. If you don't want to hear it, just I guess block out your ears, I don't know, but you can always come back, look at it, and work on it by yourself. But basically, here's the solution. It's basically just we're C outing, hey, input your name, and then we're taking in from the console whatever the user writes down. And then we're C outing, hello, and then what we stored the input from the user as, and then just an exclamation point. Pretty straightforward. C out and C in can be a little bit weird though. It's a little bit to just kind of like play around with it. It's easy to play around with, easy to figure it all out, but yeah, so there's that. And then moving on is we have vectors. So what vectors are is basically they're an array that can change size. So the reason arrays can't change size is because they're continuous in memory, but vectors aren't. They're kind of scattered throughout memory and just saying, here's the other part of my vector, here's the other part of my vector. So you can actually add to vectors and make their size bigger. And in order to use vectors, you need to have that header at the top that is #include vectors. And vectors are pretty straightforward in that I personally like vectors a lot more than arrays because I like to be able to change the size of a container. But yeah, and on the right, we just included some functions that you might find useful when using vectors, so you can also always refer back to when you're looking to play around with them.
Okay, so pointers and dynamic memory. This part is a little bit harder to understand. This is also something that you learn if you want to take more advanced C++ classes. But basically an easy preface to this is that pointers are basically memory locations. They are pointing to a memory location where your information is. So if I had a book on a bookshelf, a pointer would be like a card that says it's on the bookshelf, right? It's not the actual location, but it's pointing to where your data is. And then for dynamic memory is just a spooky kind of memory that's a little bit more complicated to use because you control when you create that memory and when you get rid of it. So if you want to control the lifespan of your variable, dynamic memory is what you would use. Because most of the time when you declare a variable inside a set of brackets, it automatically deletes at the end of that bracket. That's standard, like how variables work, like where do they go. But dynamic memory, if you use the keyword new and you say new integer or something like that, that means that you're creating an integer in dynamic memory and then you yourself get to delete it when you're done with it. Again, this is a harder and more complex topic in C++, and you wouldn't need to know it if you're just doing basic stuff, but something to preface just in case you ever have to encounter it, which you definitely will if you end up taking upper level C++ classes or go to the University of Michigan and do computer science here.
Yeah, and then we also included just kind of more links if you are a little bit more into like computer science and C++, and you feel like you want to take that next step. We did include some links for you guys to look more into that, but since this is more of a crash course, we're not going to go too in depth with it. All right, and then next we have classes and objects. So remember, C++ is an object-oriented language, and basically what classes and objects are is we're basically making our own special data structure in a way, and we're basically like obviously there's no student variable in C++, right? So we want to make one of those ourselves, and it's going to store what we want to know about a student, so name and age, right? So great way to explain it is encapsulation, which is just wrapping similar code in one place. It makes it easier for the programmer, and anytime you want to reuse code, it also really helps. Just one thing to know about classes and objects is that member functions and variables, which is basically just your functions and the variables inside of a class, are by definition going to be private, or by default going to be private. And that just means no one can touch this or look at it except for themselves or their friends. And we're not going to go into friends, but I did leave a link if you wanted to learn more about that. But if you would like it to be accessed outside of the class, outside of those brackets, you need to include a public, like I did in the example to the right. Again, classes and objects are a little bit more complex of a topic. They aren't as complex as pointers and dynamic memory. So if you are looking to really get into C++, I'd say really get into classes and objects, and then really get into pointers and pointers and dynamic memory, sorry. But yeah, on the right is just an example I put together. So I have this student class, and I have set up to where when you create a student, we're going to take in their name and their age, and it's going to wrap it all together so that maybe you can have like a vector of students called my class, and you want to add a bunch of students to that. But then kind of the question comes, well, if we're going to have a vector of my class, what if we want to have like a vector of all the classes in the school? Should we have like a vector of a vector? Should we have, it's a slippery slope when you just keep adding to the scope of things. So that's another reason why classes and objects are a great thing, because maybe you want to create a class called my school, which is going to have a vector of all the classes in your school, which is going to have inside of it a vector of the students in certain classes. It all just wraps everything together a lot better than if you just kind of threw out the code everywhere and was just kind of throw everything together, if that makes sense. And here is just kind of building off of that. You can have maybe class of students, and then you can actually have inside of like a class of like a school class vector of the students, and then also like a string of the teachers. It's just a way to wrap everything together so that it's all in one place, it's reusable, and it's just a lot easier for other people to read and understand when they're looking at your code.
So libraries. These are built-in software components that can provide solutions to various tasks so that you don't have to. Basically, there have been a lot of people who worked on C++ as a language, and they have created a lot of functions that you can use instead of having to rewrite it yourself. So like, for example, vectors, right? They're a lot easier to use than arrays. They're basically just arrays where you can change the size of them. If you know Python, they're like lists. So basically, we can use vectors. That's a library, because we don't have to code the code it would take to use an array that changes size. Or, the printing function. Like, we don't have to write the function for printing. So all these like extra functions you use to do extra little tasks that are already written are part of libraries.
And then we just included kind of a reference that you can click on if you want to look more into all of the libraries of C++. There are a lot. So that's just kind of a reference of it. You can search up different ones, see what they do. Just a very useful tool. And when you're learning C++, not even like professors who are teaching these classes know every single library. Like, they're just something that you can reference and kind of look up, like, did someone already figure out this solution for me? And if so, what should I include so that I can use it? And then here was just kind of more into that. This one that we're using the hashtag include string library, which allows you to use this get line function you can see on the right. You can kind of see the difference between these two. If you didn't have that get line, you couldn't have spaces in your input for the user input. They couldn't have spaces. So if you wanted to say something like eat your vegetables, you can't. You'd have to have underscores or some other way to connect it, because the computer won't be able to understand that you want to include those spaces. But this is just a way of someone wrote the code for you, created this get line function for you, and you can use it at your disposal. Yeah, that's all we have for you guys. Are there any questions or anything, or?